Okay, so we're going to try connecting up the ZX Spectrum. You can see it's got 9 volt DC on the back. TV port just goes to the RF. I've plugged in and I have pre-tuned. Let's plug in the power and see what happens. Yeah, nice. That is not supposed to happen. Okay, let's get this flipped over and pull it open. You can see it's got some glue or something stuck all over it. Sorry for my hairy arms getting in the way everywhere. Okay, now you do have to be careful when opening this guy up because there are some very fragile ribbon cables inside. I'm worried I may have already damaged these the first time I opened it up, but hopefully we're all good. Let's put this aside. Time for a research break. So I did some Googling. I just started by searching for ZX Spectrum troubleshooting information. YouTube video there, Adrian's Digital Basement, good channel, but I didn't actually watch this one. What I ended up finding that I found useful was this page from retrolium.co.uk about repairing ZX Spectrums. This page lists quite a lot of different possible faults with the ZX Spectrum, along with symptoms and possible diagnosis steps. I had quite a bit of a read through this, checking a few things, but eventually I settled on this section down here about no boot, i.e. the Spectrum comes on but you don't get the copyright message. And then there's a specific symptom in here about the display showing thick white and black bands and flashing attribute blocks, and that looks pretty much like what we saw when we turned the Spectrum on. The first diagnosis step that it suggests is to check the RAM chips, specifically the lower RAM chips. Testing the voltages coming in is the thing to do. So we should get minus 5 volt, 12 volt and 5 volt on 3 of the different pins. If the minus 5 or 12 volt are out, then we need to check some transistors. So let's have a look. Essentially, what we need to check is that the voltages are correct. So this is an old power adapter, so the first port of call is that maybe the voltage is coming in wrong. So if we plug it in, switch multimeter to voltage. I'm going to check this heatsink here is connected to the ground plane. We can see here that we're getting 5 volts. Now this here is a 5 volt regulator, so that's what we expect. So that looks good. Now, following diagnostics online for the visual issue that we were receiving, the thing to check is actually the voltage on the RAM, because often this can be caused by corrupt video RAM, causing bad picture to go to the television. So what I'll do is I'll just switch hands. The RAM here, I'll probably bring up a schematic. The RAM here has 3, so 1 ground pin, a minus 12 volt pin, a plus 12 volt pin, and a plus 5 volt pin at each corner. So by comparing the voltage to the ground, we can check each pin and we can see what the readings come up as. So see there, we're getting the 5 volts, that's correct, that's a 5 volt pin. Up here, $4 volts. That's actually a data pin. No, sorry, there we go, that one there. So that's ground, which is correct. Up in this top corner here, Now we're getting it's showing minus 115, minus 100 millivolts. And down here we're getting, see, we're getting 9.45 volts. Now that's the plus 12 volt rail. Anyway, so we can see that the voltage, there's a voltage problem on the RAM. I did test multiple RAM chips and they all seem to be getting a similar sort of voltage issue on their plus 12 volt rail, plus 12 volt pin. According to some research that I did on the internet, the problem, if there's voltage issues with the RAM, that can cause a video problem, and then that can be caused by failures in this section up here, roughly, which is where voltage sort of comes off the power supply and gets routed out to the board at different levels. So we tested the 5 volt was coming in good here, and the 5 volt was good there, but the voltage does get adjusted here, and that's where the 12 volt comes from. I'm not an electronics expert, so I don't know all the details, but I guess the diagnostic guide that I said was to check these two transistors, because these are used in that voltage distribution. Now, the recommendation for testing these transistors was basically just check for continuity, i.e. a short circuit, between any two of the pins on the transistor. So a transistor that's working correctly when the device is powered on should not have, in most cases, my understanding, should not have a short between any of the pins, because continuity is only achieved between pins on a transistor based on the voltages coming into other pins on the transistor to allow for the switching and logic that transistors let you do. So by default, they should not be shorted together. So what we're going to do is switch the multimeter. I'm going to switch it into continuity mode. So makes a noise. We get continuity, ground plane, we get continuity. If I test, for example, a couple of resistors here, we don't see anything because there's enough resistance across them that the continuity check doesn't flash. But if I check on there, works good. Diode. Interesting. I don't know how all this stuff works. I think these are capacitors. Yeah, these are caps. Okay, anyway, transistors here. So if we look at, we'll come around to this guy. This is TR5, I think. If I might not be able to see this. Okay, so I'll try to get a bit closer here with the camera, but it's not great. So again, we're on continuity, so I'm going to check these transistors. So we've got 3 pins. So I'm going to check this pin and this pin. Nothing. This pin and this pin. Yep, nothing. And this pin and this pin. Nothing. So that's what we'd expect. This transistor over here, TR4, this pin, nothing. These two, nothing. But these 2 pins are showing a short. So again, nothing, nothing, short. That should not be happening. Now that indicates that transistor has a problem and needs to be replaced. Okay, so there is just a single screw holding this motherboard onto the frame. So we'll just remove that. Okay, now it should just lift off. And I hit my light, turn that off as well, great. Okay. Now, you can see on the back what I talked about the sort of cracking and warping on the solder mask. Looks like sort of on the ground plane maybe. Anyway, I don't think that's a problem. Doesn't look like there's actually any shorts or anything like that. Now, I can see there's some flux residue on this board. on these potentiometers. Now I think these are used for adjusting the color output, so I may end up needing to play with these. I'm not sure if that was sort of amateur work or factory work. I know these were put together quite cheaply, so yeah, and I don't know very much about the history of this, but yeah, not quite sure. Anyway, I'm going to assume that's all good. So the thing we need to do is mark off this transistor, this guy here, which will be these 3 pins here, and I'm going to remove him, and yeah, see if we can put a new one in. Okay, so we're at the soldering station. Now we need to remove this guy here. So this one here. Now I could fire up the soldering iron, heat these 3 pins up, and try and wiggle it out, but because I know it's bad, I think what I'm going to do is I'm just going to use the snips, snip it out, and then remove the pins, try and wick off some of the solder, and then replace it with the new transistor. Okay. Well, let's see how we go with trying to snip this little guy out. Don't know if you can read ZTX 650. And then what I have here, the DX 651s. Okay. So, soldering iron plugged in. Press on, there we go. Heat up pretty quickly, this guy. Now, things we need to remove these 3 guys here. So, what I'm going to do to start with is just try and melt the solder. Add a little bit of my own solder. Just get a bit on the tip. Again, do not use me as an example of how to solder properly. There we go. Adding a bit just helps get a bit more heat transfer on. Leg out. Doesn't want to come all the way. Amateur hour soldering. Make this look much more difficult than it should be. I hate the soldering. Let's get this guy a bit hotter. Again, just wet it a little bit. Doing things I think I need to do without really knowing why. There we go. That's one pin removed. I'll clean up the joint shortly. That's melted pretty quick. Grabbing the soldering iron, not the pin. There we go. Heat is key. Plenty of that. Okay, come on, there we go. Out you come. Cool, alright. That's done. Okay, so we can see that I've got pins out, we've got quite a bit of solder in there, so I'm just going to try and get rid of it. With this guy. Now again, I am no expert. If we're going to burn myself or something. There we go, it seems to be doing something. Give me a face full of flux is what it's doing. Just getting the heat through. There we go. That's better. I think I'm starting to learn how this works. There we go. Perfect. Can see air. Okay, so now I just need to fix up the pins so that I can actually get it in. Based on the diagram and my understanding, it goes in this way. But we'll find out if and when I get it wrong, and it makes things worse. Hopefully we're good though. Oops, that's fuck. Oh, if that's alright. Not inserted transistors before, so hopefully we're all good. Looks about right. Just bend the pins a bit to keep the little guy steady. Now, forgive me for everyone who's watching how I'm about to do this. Actually, sorry. Flux. Cotton bud. Lather it on. Because I don't really know how to solder, so my understanding is flux is a bit of a cheat. Just get this holder off. Getting my heat transferred. The wetter tip. There we go. It's starting to melt. That looked terrible. Yeah, I need to fume extractor. It's right in the face. Looks like it's joined through the via. Well, I don't know. I think it's good enough. And I have a few backups if I did something wrong. Okay. Alright, so just going to clean it up a little bit with some isopropyl. A bit on there. Alright, last thing I want to do is just hit this with the multimeter in continuity mode. Make sure that I haven't shorted these pins together. Good. Okay, so I've done some more checking, checked some more continuity, done a bit more of a clean. Sorry, lighting is terrible. I think we're good. Let's give this a try. Okay, so the first thing I want to do is double check voltages again. See if we're getting different voltages to the RAM. Well, first of all, we'll plug it in and see if it explodes, but I assume it won't. That's a good sign. Shot. So again, 5 volt, good. Now, moment of truth. There was this bottom left pin on the RAM, I believe. Hey, 12 volts. Okay. Okay, we've got the TV plugged in. Let's plug the power in and see what happens. Aha! It works, yes! Nice, okay. If it's flashing a bit on the camera, that's just the refresh rate. Can't do much about that with the phone, I'm sorry. Nice, okay, let's get this all hooked up with the keyboard and see if it works. Okay, we are hooked up, keyboard should be plugged in. Everything should be plugged in, so let's just... Oh, video is not plugged in. Video in. Now this thing doesn't actually have a power cable, so... Not a power cable, power switch. So you just plug it in and it's on. Alright, now... Aha! Let's try 10 space print. Delete. How do I get quote? Does anyone see the quote? Oh, it's the red ones? Yeah, the red ones. Which is there. Symbol shift. There we go. Print. Hello. World. Symbol. Print. Enter. 20. Go to 10. Enter. Run. Enter. Scroll. Yes. Awesome. Well, Where is stop? Break. There we go. Cool. That's ZX Spectrum working. Job's done. Time to learn how to use it.